Okay, hi everyone. So this is the fourth lesson for our topic 5 integration. So by now you should able to actually integrate all the standard functions for integration, meaning you know how to do integration for ax plus b, 1 over ax plus b, all the trigo functions, sine x, cos x, and also secant square x. Okay, and for yesterday's lesson, we know how to integrate 1 over x squared plus a squared, and also the last one, kf prime x over fx. Okay, so if you still have any issue integrate all of this, then you might need to do some revision before you move on. Okay, so my questions is, you see, we have like all the standards functions that we have learned here. So what if we have a functions that is not in this standard form? Okay, for example, when you look at this equation, right, in differentiation, we have something called as product rule. So this is like a differentiation technique for us to solve something like UV. But in integration, we only can split something that is like plus and minus, that you split them into two integral. So that's why for today's lesson and tomorrow lesson, we are going to do three integration technique. Okay, so for today's focus, it will be the first one, which is what we call as integration by substitution. Okay, integration by substitution. And the second one is how do we use how do we integrate rational functions by using partial fractions. Okay, so I believe the first part might be a little bit difficult for you at the beginning, but the second part is going to be like quite easy. It's just going to be how do you use your prior knowledge to actually solve rational fractions by using partial fractions. Okay, so that's why I'm going to spend more time explaining for the first technique. Then after that, for the second technique, I believe that it's quite easy for you to pick up. All right. Okay, so let's try to move on to the first section, which we try to talk about integration by substitution. So the idea for integration by substitution is actually quite similar with the process of how you do differentiation by using chain rule. Okay, so the idea is that how do we actually change an integral that we can't integrate to something that is easier that we can integrate. Okay, so the idea is that when you try to do integration by substitution, right, the integral must be completely rewritten in terms of new variable. Okay, so this is important. So for example, if let's say I have a functions before that is in the variable of x, but after I change it by substitution u, right, I must make sure that the whole equation will become in terms of u. Okay, so that's the idea. Yeah, there's no theory and so on for this part. Is mainly like application. So we are going to look at few example for this section. Okay, so let's look at the first one, then I'll explain from there. Okay, so let's look at example 1. Okay, so you remember the idea of integration by substitution is to form a new integral in terms of a new variable. Okay, so as you can see, right, for the original integral, we have it in terms of x. Then we have a substitution u equals to x plus 1. So you can see our target here is to actually form a new integral in terms of u, completely in terms of u. Okay, how can we do that? So let's see, what do we have in the integral? You have x, right, which you need to substitute with in terms of u. Then you also need to substitute the term of dx. Because you can imagine, if let's say I try to change all this in u, but I need to integrate in terms of x, I can't do that as well. So that's why I need to change the dx in something that in terms of u also. Okay, so how can we actually do that? So the first thing that we always do, right, is start from the substitution that given from the questions. So u equals to x plus 1. So if I differentiate it, what do I get? I get du dx equals to 1, correct? Then by moving around this equation, then I will be able to get dx equals to du. Okay, so just move the dx up there. So become dx equals to du. So you can imagine later I'm going to substitute the dx here with du. Okay, so let's look at the second part. So we know that x plus 1, obviously we can try to substitute the whole thing here by u, right? But how about 2x minus 1? So I need to get an equation that tells me x equals to what? So I have u equal to x plus 1. So I know that x equals to u minus 1. Okay, so with everything ready, then now I can try to substitute inside. So my integration for 2x minus 1, x plus 1 to the power 5 dx. Okay, so now I try to substitute everything here. So 2, then I have 2x minus 1, which my x is just u minus 1. Okay, then minus 1. All right, I just substitute the x here. Then after that, x minus 1 is what? Is u, right? To the power of 5. Then what is my dx? Dx is du. So you can see I get a completely new equation, like new integral in terms of u now. So can I integrate? Yes, of course I can integrate a u expression with respect to u. So, but it seems like very hard to integrate that, right? So let's try to simplify it. So 2 times u, so let's try to expand it. So you have 2u minus 3. So u5. Okay, so now we can try to expand them. So you have 2u to the power of 6 minus 3u to the power of 5. So now can you actually integrate this? Yes, you can do that. So 6, then what is that become? So 2 over 7 u7 minus 3 over 6, right? You have 1 over, okay, let's try to write this first, over 6. All right, and don't forget plus c. Okay, so after you get your answer in u term, and don't forget your questions is actually ask you to do the integration in terms of x. So after doing your substitution, we need to change it back to x. So what is u? U is x plus 1. So that's why 2 over 7 x plus 1 to the power of 7 minus 1 over 2 x plus 1 u. Okay, then after that plus c. All right, so this is how we get to our answer. Okay, so if you want, then you can try to like play around, meaning that you can try to check when you try to do integration, do you actually get back to the exactly same thing? Yeah. Okay, that's it for number 1, which I think the idea is pretty easy, meaning that what you need to do is to form a new integral by using substitution. Then after that, you do normal integration, and at your last part, you are going to substitute whatever that you have substituted just now and try to make it back into your original variable. Okay, so that's the idea. So let's move on to number 2. Okay, so let's try to look at number 2. So the same thing, maybe let us try to start with the differentiation first. Okay, so what you need to do is by substitution, u equals to 2x plus 1, and to transform the integral here as well. Okay, so u equal to 2x plus 1. So when we try to differentiate it, then we get du dx equal to 2, correct? Okay, so when we want to substitute with the dx, meaning that we need to exchange their place, right? So you get du over 2. Okay, it might look a little bit awkward in this, but don't worry, after you substitute it, then you will see the whole picture. Okay, so the same thing, you can see that for 2x plus 1 is going to be substituted by u. So how about the 4x here? So that's why we know that u equal to 2x plus 1. Okay, so since 2x equal to u minus 1, so we know that for 4x is going to be 2u minus 2. Okay, so later we can straight away substitute this. So the integral for 4x, 2x plus 1 dx. Okay, so please make sure you don't write like this in your exam. Okay, I mean you can't write in 2 columns. So I'm just I want to show you in like the whole image, so we do not need to like scrolling up and down, and it's easier for you to see also. Okay, all right. So when you reach this step, then you can continue. So equal to, it depends on you actually. If you want to move the 4 outside, you can do that as well, because it's a constant, right? So if you want to move the 4 outside, you can do so. Okay, So if you don't want, then we will just continue. Or in this case, you can choose not to do that, because the idea is if you take out 4, then later when you substitute inside, then you have a fraction. Okay, then later you will need to take out again. So 2u minus 2. So what do you have here? Square root u, correct? So it becomes u 1 over 2. Okay, then what is dx? Dx is actually du over 2. So du over 2. So you can see now we have a totally new integral as well in terms of u. So now let's try to continue to simplify. So you can see this is divide by 2. So since you have 2u minus 2, so I can change it to u minus 1. Okay, then after that, the same thing, u 1 over 2, and with respect to du. Alright, so now I can continue it. So what do I actually need to integrate? U to the power of 3 over 2 minus u to the power of 1 over 2 with respect to u. Okay, so now we can start the integration. So plus 1 and divide, then you get 2 over 5 u, 5 over 2, and then minus 2 over 3 u, 3 over 2, and don't forget plus c. Okay, so for now, you can try to substitute back into x already. So what is our u? Is 2x plus 1. So 2x plus 1 to the power of 5 over 2 minus 2 over 3. So 2x plus 1 to the power of 3 over 2 plus c. Okay, so this is our last answer. Alright, so after that, let's move on to number 3. Okay, so use the substitution u equals to x plus 1 to actually find the finite integral here. Okay, so let's try to do the same thing. So u equal to x plus 1. Alright, then du dx is actually equal to 1. So it's the same thing, we get du dx here. Okay, which we get du equals to dx here. Alright, then after that, you can see that you have a x here, so we need u equals to x plus 1, and our x is actually equals to u minus 1. Okay, then I think we can substitute everything here already, so this will become u minus 1, then after that, square root u, and our dx will become du. Okay, but there's one more thing that we didn't change yet. So you can see the limit here is actually in terms of x as well. So now since we change our u in terms of x already, right? So meaning that we will need to change the limit also. So if the x is equal to 0, what is that in u? So u equals to x plus 1, right? So if x equals to 0, then u is 1. So if x equals to 3, what is u? U is equal to 4. Okay, so later when you try to change everything in terms of u, you must make sure that the limit will be changed to 1 and 4 as well. Alright, so now let's try to do the substitution. So 30 x over square root x plus 1 dx. Okay, so now same thing, change the limit. Alright, so 1 to 4. So don't forget this, because if you do this wrong, then later when you substitute, then you might get some mistake because of the limit. Alright, so what is the x? X is u minus 1, then divide by square root u. Okay, then now dx become du. So let's simplify it. So equal to 1 over 4. So u over u 1 over u over u to the power of 1 over 2, you get u 1 over 2 minus u negative 1 over 2. Okay, so now we can start the integration. So plus 1 and divide, so you get 2 over 3u, 3 over 2, and then minus 2u, 1 over 2. Okay, so now we can try to do the substitution. So 3 over 2, 4, 3 over 2 minus 2, 4, 1 over 2. Okay, then minus, so we know that we substitute and substitute, you will get 1 as well, right? So 3 over 2, 1, minus 2, 1, 1 over 2. Okay, so trying to write down your answer. So you have 16 over 3 minus 4 minus 2 over 3 and also 2. Alright, so your last answer should be 8 over 3. Okay, every time when you do finite integral by using integration by substitution, so you will need to change the limit. Alright, okay, so let's move on to number 4. Okay, starting from number 4, we are looking at the functions that not only in simple x, we are going to look at like exponential, natural logarithm, or even trigonometry, which might get a little bit harder here. But of course, I think question 1, 2, 3, if you roughly can get the idea already, you can try to do it by your own. Then if you can't get the answer, then you can come back to the lesson. Okay, so by using the substitution x equals to e to the power of u, then find this. All right. So since we want to find du dv dx in terms of u, right? So same thing. So x equal to e to the power of u. So you have two choices here. Even I mean, you can do dx du also. I mean, by all means, after that you are going to get dx du. So it depends on you whether do you think that it's easier for your solution to have derivative of eu or to have the derivative of ln x. Okay, so you see when after you differentiate eu, right, then what do you get? You get back eu. But after you differentiate ln, right, what do you get? You get 1 over x. So that's why actually in this question it's simple if we try to change it to u equals to ln x. Okay, so if x equals to e to the power of u, then u equals to ln x, right? So what is du dx? So du dx is equal to 1 over x. So since we need to substitute the dx later, so dx will be equal to du over 1 over x, right? Du over 1 over x, which exactly give you x du. Alright, so that's why it's simple for us to change it into this form. Okay, so now I will try to see do I have any other thing that I need to substitute. So you can see I have a ln x here. So what do I need to substitute for ln x? So ln x is basically equals to u, right? Then what is 1 over x? Yeah, so 1 over x here, I have eu. So I will try to substitute and see what are the things that I will need to do. Okay, so same thing. 1 to e 1 over x ln x dx. Okay, and don't forget you have a limit here. So if x equal to 1, so what is your u? So you can see u equal to ln x, right? So ln 1, what do you get? Ln 1, you get 0. Okay, then after that you have x equals to e. So what is your u? U equals to ln e. So what do you get for ln e? You get 1. Okay, so that's why your limit will be changed to 0 to 1. Alright, so now we can continue. What is 1 over x? X is e to the power of u. So 1 over eu. Okay, so our ln x here, just now we say is u already, right? So u. So what is dx? Dx is basically equals to x du. So x du. Yeah. So you can see you have another x here. So how are you going to do that? So substitute again. So or in the other way, if you don't want to change this, right, then what you can realize is I have this term which is originally is x. Then I don't change it. So 1 over x, what is ln x? Ln x is u. Correct? Then after that, what is my dx? My dx is x du. So you can see that 1 over x multiplied by x, you get 1. So this is how I eliminate it. So 1, 0, 1, and then u du. Okay, so you can see from this equation, it becomes something that much more simple already. Then now I can try to do the integration. So u2 divide by 2, then I substitute 0 and 1. Okay, so which I'll get 1 over 2 minus 0. So my answer is 1 over 2. Alright, as simple as that. Okay, so let's move on to the next questions. Okay, number 5. We have a trigger here, and this question is actually a little bit harder when we compare to 1 to 4. Okay, but the idea of this integral is actually you can solve this by what we have learned yesterday, and I mean, it's not necessary for you to do substitution, but if the question requested for substitution, then you need to do substitution lah. So if not, then just by looking this, you should able to know that you can actually do 8 over 1 over x squared plus 2 square dx. Okay, which what do you get after that? Then you get 8, right? Then after that 1 over 2, so you get 1 over 2 tangent negative 1, then 1 over 2x. Okay, this is what we have know. This will be our last answer. Yeah, so maybe later when we try to do it, then you can try to check whether your answer is correct or not. Okay, but as what I say, if the question didn't request you to use substitution, then please just use the formula that we have learned in standard fractions, in standard functions to just solve it. Yeah, it's going to be longer when we try to do in substitution. Okay, so let's try to do this. So the same thing, you have x equals to 2 tangent u. Okay, so what we try to do is differentiation as well. So you have dx du equal to, okay, you might have a questions here. Do I need to always change it into the form of u equals to what, then only I can continue? You can. So for example, if let's say for this one, right, if you want to change it, then it will become u equals to tangent negative 1, then after that tangent negative 1 x over 2. Okay, so you already know how do you actually differentiate this, right? So you can do by this term. So if you don't want to do that, you can do second also. You will get the exactly same answer. Okay, I think it's easier, in this case, it's easier for you to do this. So you can try this out by doing this as well. So I am trying to go for the way for second square. Okay, because that one is going to be harder. So this one, right, then after you do this, then you just change it into du dx, then you continue to solve it and substitute. Yeah, you will get the exactly same answer one. Okay, you can try that by your own. So but I'm going to show you in a harder way in case you want to do second. Okay, so dx du is equal to, so after you differentiate, then you get 2 second square u, right? Okay, then now you need dx. So what is dx? Dx is equals to 2 second square u du. Okay, so now we might need to continue. So let's try to substitute. Okay, because you need in terms of x, right? So you know that x is equals to 2 tangent u already. So now you can try to do substitution already. Okay, but at the same time, you also know that at the end, you need to substitute back into x. So that's why it will be helpful that you can write it down first. U will be equals to shift tangent, then x over 2. Okay, so this is the another way that I can say, I say you can continue. So du dx, then you substitute here instead of doing second. Okay, so 8 over x squared plus 4 dx. Alright, so the first thing that you can try to do is you do the substitution first, because we need to check whether you have something that you can factorize together, so you don't take out the 8 yet. Okay, so what is your x? So your x is 2 tangent u square plus 4. Okay, so what is your dx? Your dx is 2 second square u du. Okay, so now we can continue. So when you expand it, then what do you get? You get 4, right? So 8 over 4 tangent square u plus 1. Then plus 4. So 2 second square u du. So now you see that you have two variables here. So how can you solve each other? So you have learned identities before, right? That you have one identities that actually tell you that second square x is actually equals to 1 plus tangent square x. Okay, so this is the identity that we have learned previously. So we try to substitute here. So what do we have here? So 8 over 4 tangent square x plus 1. Okay, so 2 secant square u du. Alright, so you can see 8 and 4, then you have 2, right? Then you can just 2. Okay, so what is tangent square x plus 1? You get secant square. Okay, sorry, this should be u. Alright, then after that, multiply with 2 secant square u du. Then after that, what do you get? So after you actually simplify, you will be able to get 4. Okay, so as simple as that, then you can continue. So you have 4u, right? So 4u plus c. Okay, then now you can substitute back. So 4 tangent negative 1 x over 2 plus c. Okay, and you try to check with your answer just now. So 8 times 1 over 2, you get 4, right? So 4 tangent negative 1 over 2x, which is exactly the same with your answer over here. Alright, so this is how you can do it. Okay, and I believe that if you try to go through the other way, which is try to use this one, then it will be easy because you do not need to go through the process of secant square. Alright, okay, so let's move on to the next one. Okay, so number 6, I believe this question is a bit difficult. Okay, so but yeah, I mean, let's try to go through it. So it's the same thing. So we need to use a substitution x equals to square root 5 over 2 sine x to find the integral here. Okay, so x equal to square root 5 over 2 sine theta. Okay, so I mean we didn't learn the differentiation for sine negative 1, right? So that's why you wouldn't want to change it into theta form, then you continue. So we need to differentiate here. So dx d theta will be equal to square root 5 over 2. So sine theta will become cos theta. Okay, so since you want dx, so that's why dx will be equals to square root 5 over 2 cos theta d theta. Okay, so later we might need to change back the theta to x, then you can write it here as well. So theta will be equals to, so we straight away change it, so shift sign, then after that you have 2 over square root 5x. Okay, but you do not need to do your d theta dx here because we can't differentiate sine negative 1. I mean you can, but in our syllabus we don't do that. Alright, so let's continue to do that. Okay, so substitution 1 over square root 5 minus 4x squared with respect to x. So let us try to substitute 1 over square root 5 minus 4, your x is square root 5 over 2 sine theta. Alright, then after that dx, what is your dx? dx is square root 5 over 2 cos theta d theta. Okay, so you can see if we want to simplify, right, we might need to change this form in cos as well. So we can try to simplify that. So 1 over, so let's try to expand it first. 5 minus, okay, so you can imagine when you try to square it, then you get 5 over 4, right? Then after that, you should get 5 sine square theta. Okay, then square root 5 over 2 cos theta d theta. So as you can see, we can't change anything for cos theta already, but we can change the sine square theta. So what we can try to do, 5, okay, factorize it, you have 1 minus sine square theta. So what is 1 minus sine square theta? You will get cos square theta, right? So later we can substitute, then simplify with the cos x here. So 1 over 5 cos square theta. Okay, so you must show the step that how do you change all those identity. So after you simplify, then you will be able to get 1 over square root 5 then cos theta. Okay, because you have a square, then you square root, right? So square root 5 cos theta. So square root 5 over 2 cos theta. So now you can try to simplify it. So what you can see, so cos theta and cos theta, then square root 5 and square root 5. Then after that, what do you left? You left with 1 over 2 only. Okay, so d theta. So now we can try to integrate this. So you get 1 over 2 theta plus c. Okay, so now we try to change it back. So 1 over 2 sine negative 1, 2 over square root 5 x plus c. Okay, so if you rationalize it, then you will get 1 over 2 sine negative 1. Then after that, 2 square root 5 over 5x plus c. Okay, so that would be your last answer. Okay, so let's move on to the last question. Okay, number 7. So if you want to try it out first, feel free to do so. Okay, so the same thing. Let's start with the equation first. So u equal to sine x. Okay, so the same thing, if you want to change the object as x, then it might be difficult for us because you didn't learn the differentiation for sine negative 1. So that's why we just move on with du dx equal to sine x. Okay, so since we want dx, meaning dx will be equals to du over cos x. Alright, so now let's try to check what do we have in the integral. You have sine square 2x. So you might have some trouble here, which you can see your u is in terms of sine x. So you can imagine later when you try to substitute, right, you do not have anything to substitute this term. Because sine x, even you square, you also get sine square x. So how are you going to get sine 2x? Then we might need to use formula. So how do we do that? So we know that sine 2x is actually equal to 2 sine x cos x, right? So since in this case, we want to get sine square 2x, so we square the whole thing. So sine square 2x will be equal to 4 sine square x cos square x. Okay, so later we can try to substitute this inside. And now, any problem do we have? Okay, you see you have a cos x here. How are you going to substitute u as cos x? So the same thing over here as well. Even you try to change it to 4 sine square x cos square x, right? But the substitution that you have is u equals to sine x. So how can you substitute for the place for cos square x? Okay, you might think that maybe you have something that you can cancel off. Okay, maybe let us try to put them into the integral first. So the integral for sine square 2x cos x and dx. Okay, so let's try to continue this first. So sine square 2x equal to 4 sine square x cos square x, right? Then after that, you have another cos x. So what is your dx? Your dx is du over cos x. Du over cos x. Okay, so now what you can try to see here for, so you have sine square x. So let's try to write it first. You can see that the cos x and the cos x here, they can cancel out each other, right? So what do you left? You left with cos square x, then du. So you are not in the form of a new equation here yet, because this is in terms of you need to integrate with respect to u, but the idea is you have them all in terms of x. So if you want to substitute, you only can substitute sine square x in u square, right? So how about cos square x? So you might get some problem here. So can you change cos square x into sine square? You can do that, right? So integrate for sine square x. What is cos square x? So 1 minus sine square x. Okay, so now you can try to substitute. So for what is sine square x? So sine square x is basically u square. Okay, minus u square also. Alright, du. So now you have a totally new integral in terms of u already. So we can expand it. u square minus 4u4. Okay, so we can try to do the integration now. So what do you have? It depends on you whether you want to take out the 4 or not lah. So I mean, by all means, you are still getting the same answer and you are not going to do any finite integral, so that's fine. Okay, so what do you get when you plus it? So 4 over 3 u to the power of 3 minus 4 over 5 u to the power of 5 plus c. Okay, and at the end, we need to substitute what is your u. So 4 over 3 sine cube x minus 4 over 5 sine to the power of 5x plus c. Okay, so please make sure that we can try to do sine cube is because of we know that u3 is equal to sine x cube, right? So that's why this is exactly the same with sine cube x. Okay, so the same idea for sine to the power of 5. Okay, so that's the idea for substitution. So I guess the tricky part is when it involves trigonometry. So you know that in your process, right, you might need to put in some of the identities of the formula that you have learned previously. Alright, so now let's try to move into the second section. Okay, for the second part, we are going to talk about the use of partial fractions in integration. So for all algebraic fractions that you cannot directly integrate it, then what you try to do is you need to express them into partial fractions. Okay, then the partial fractions will be something that you can integrate them. Okay, so let's try to look at some of the example here. So you will see in the video, I'll try to cut all the part where I try to do the partial fractions because those are the things that you already learned already. So that's why you can just go through the process by yourself. So I'm going to stop right before the integration. Okay, number 8. So as you can see, this is algebraic fractions, which is combined by different partial fractions. So obviously you can see that this is not something that you can directly integrate. So that's why we need to change it into partial fractions first. Okay, so please try to change it by your own. So I'm going to fast track for this process. Okay, so after you have reached this step, then this is how integration come in. So instead of integrate 3 over x plus 1, x squared plus 3, we try to integrate the partial fraction. Okay, so 1 over x plus 1 minus x squared plus 3. So you'll realize that comparing to the previous algebraic fractions, right, this is definitely the one that we can integrate. Okay, so what is this? This is f prime x over fx that we have learned yesterday. Okay, so what's the integration for this? Then you have ln x plus 1. Okay, so how about for the second part? So you can realize that after you integrate, you get 2x, right? So that's why we can't actually integrate that part yet. So 1 over 2, okay, then 2x, x squared plus 3 dx. Alright, so now you can integrate this part as well. So ln x plus 1 minus 1 over 2 ln x plus square plus 3 plus c. Okay, so as what you can see here, so make sure that every time before you integrate them into ln, right, you must make sure it's f prime x over dx. Okay, so as simple as that, you can just leave your answer like that because you have 1 over 2, so it's not necessary for you to combine. Okay, so that is your last answer. Okay, so let's move on to the next question. Okay, B, same thing. Let's try to start with the partial fractions first. now we can start our integration. Plus 2x minus 1, the whole thing, 1 over minus 1 plus. So it's easier for us to change it in this form because later you are solving it in terms of composite function. Okay, so let's continue to do that. So maybe let us try to split them into 3 first. Okay, minus plus, leave 3 outside. So x minus 1 negative 2 dx. Okay, so now we can integrate them one by one. So you have ln x plus 2, ln x minus 1. Okay, so make sure that you check, okay? So because you differentiate, you get 1. You differentiate this, you get 1 also. So that's why you can change it into ln. So plus 3. So this is integration in the composite form. So that's why power plus 1, then divide by the power. So you have negative 1. Then when you divide the whole thing by your derivative, which is 1, then you get the exactly same thing lah. So here become power negative 1. Okay, and don't forget you have a 3 outside later. Okay, so whole thing plus c. So now you can combine these two together. So ln x plus 2 over x minus 1. Okay, then minus 3 over x minus 1 plus c. Okay, so this will be your last answer. So move on to the very last example, which we talk about where you have to deal with the long division. Okay, so for A, I'm showing you the idea for a linear factor. Then after that, we move on to like a repeated linear factor. So for this term, we are going to look at improper fractions, where you can see for the numerator and the denominator, you have actually the same degree. So you can see the highest power are both 3. Okay, so that's why we might need to find out quotient by using long division first. So let me try to do in this case. So actually you doesn't need to do long division before you move on. Okay, so you know that when you try to expand your numerator, right, you are going to get x cubed minus x squared. So that's why when you use x cubed to divide by x cubed, you can roughly guess what's the first number that you are going to divide. So in this case, you can imagine that you are going to use 3x cubed divided by x cubed. So what is the number that you will put? It will be a 3. Okay, then after that, you don't need to care about it anymore. So you can just continue plus a over x, okay, and plus b over x squared, and plus c over x minus 1. Okay, then from there, you can continue with whatever that you need to do always. Okay, let's continue with the integration. So integrate 3x cubed minus 4x squared minus 2 over x squared x minus 1 dx equal to 3. Okay, so if you want to, later we can try to, yeah, so it's the same thing lah. For this one, I think it's easier for us to just change it. Okay, or maybe you can copy first, then later we try to come back. Okay, minus 3 over x minus 1 dx. Okay, so now we try to split them. So you have 3. Okay, so this one, if you want, you can take it out as well. Okay, so for this, you realize that you will be solving x negative 2, right? Then after that, minus 3. 1 over x minus 1 dx. So now you can start to do integration. So 3x plus 2. So 1 over x, after you integrate, you get ln x. Okay, then minus. So how about for this part? So x minus x negative 2. So when you integrate, sorry, this is plus, you should be able to get, so plus 1 you get negative 1, so divide, you get divide by negative 1, right? So negative x negative 1. Okay, and minus 3. So for this part, 1 is the derivative for x minus 1 as well. So ln x minus 1 plus c. Okay, so now let's try to simplify your answer. So 3x plus 2 ln x, okay, and then plus 2 over x minus 3 ln x minus 1 plus c. Alright, so if you want to, then you can combine these two together, but I guess it's not necessary lah. But if let's say you want to do that, then your final answer will be equals to 2x plus 3 over x. Then after that, you imagine the 2 will become the square, right? So plus ln, this is minus, so that's why it becomes divide. So it will be like something like x squared divide by x minus 3 cubed. Okay, so if you want to simplify further, then this will be your last answer. All right, so we will end the I'm sorry, I think I do a mistake here. Yeah, this should be negative. Okay, so please check it out. Yeah, so we will end our lesson here for today. Okay, so for the last part in your handout, we are going to cover it tomorrow. So it's just a very short one, and tomorrow we only left with one last integration technique, which is integration by parts. So we can try to do it together tomorrow. Okay, so but don't worry, it's not going to make any difference with the exercise that you are going to do, because the idea is that how do you actually use integration in partial fractions. Okay, so that's the idea. All right, so please try to spend your time to finish your homework, then submit before the time. Okay, so that's it for today's lesson, and I'll see you tomorrow. Thank you.